This whole course curriculum used to be an on-site course that we taught, well, primarily on-site. It used to be 2 days in person at our facility that we in Phoenix, or actually Scottsdale, Arizona, and then we would have these 3 longer remote sessions. And then we realized there's a lot of content to absorb in a short amount of time. So we decided to just go from having those on-site sessions and move towards a hour a week, hour every 2 weeks, sorry. So that's why we skipped some of these. And the first 5 topics were really around business and organization. It was targeted to CTOs and emerging CTOs. So understanding more about the business, how to engage with business stakeholders, some basic accounting, how to think about technical debt. Org design was really about small, durable, autonomous teams, and then OKRs. Then we spent 5 sessions on architecture, really understanding distributed architectures and how to do high availability with distributed architectures. Those were 5 sessions. And then the next 3 were a bit of process and product, where we talked about the different ways of working, Agile, Waterfall, and Kanban. And then we had 2 sessions for everyone on introduction to product management, which was strategic concepts, how to think about total addressable markets, service addressable markets. And then we got into more techniques around designing for customers, where we talked about jobs to be done, journey maps, and process mapping. Not process mapping, sorry, personas. That was really the April 25th session. So our last session we had 2 weeks ago was an introduction to big data. And in that one, we described the difference between induction and deduction and how different parts of the architecture lend themselves to that different kind of analysis. We introduced the concept of the hermeneutic circle and also the DIKW, data, information, knowledge, wisdom, and we used some Moneyball videos to describe that. So today we're going to focus a little more on architecture and also a challenge that we see for a lot of our clients, particularly those that are in the software as a service space, for internal stakeholders and for external stakeholders. So we'll get done with that today. And the DIKW, for those of you that were not here last week, that's data, information, knowledge, wisdom. It's a chain and a value chain. So this historically goes back to how we thought about data warehousing. That was a term that started emerging, I saw in the market in the early 90s. And the challenge then was, how do I aggregate information from multiple transactional systems? So you had your data assets on the left side. You would have an operational system or 2, typically 1 or more online transaction processing systems, and then an operational data store, which is really the operational view across multiple transactional systems. And then we moved our analytics into either warehouse, where we started denormalizing data to make it easier to query, and then smaller data marts. And ultimately, the data products were front end. So there have been a lot of variations over the years with data warehouse vendors. Early ones were called Redbricks, was one of the early ones I recall. Oracle had some point solutions. And now we've moved into a world where a lot of folks have gone all the way to Snowflake, or are using Redshift as the primary tool that people are using for a data warehouse. So what's a bit unique historically, though, is this was always historical data looking backwards in time, and it was missing a real-time aspect. So just looking at this view, typically the proper data flow that we like to see is a lake in front of a warehouse. And the flow is this narrowing view of getting more focused of data. So on the far left, it's a broader sense of data, and there's potentially a lot more source functionality. And it's really not designed for structure, though. The data is not, it's maybe less structured, or it was more highly structured for the transactional systems, and it's not designed for speed of querying that data. And so that's where the lake is drawn visually, large on the left side. And then as you go into a warehouse and a mart, the breadth of the data is narrowed, and the functions, meaning the domains, the business domains that they cover, is narrower. But in return, you get structured data within those domains designed for rapid querying. And that's why we typically need to reshape the data as we move it that way. Now, conversely, though, the number of instances is different. So although the size of the instances is very large, your lake could be enormous. It could even have all of your historical data, typically in your cheapest storage. As you move to the right, those instances get smaller, and you may even have more expensive storage and more expensive machines for performance. And so you may have more and more instances. So the analogy is, think of from distributing the data from a warehouse to a superstore all the way down to convenience store. So that's the analogy of this kind of analysis and this type of model. So this is a busy slide here. On the left side, these are all the data assets that you have access to either inside your environment, and those are your transactional systems, documents that are floating around. There's also data outside of your company, social media, blogs, but we're weaving in more machine learning and more scientific data. So in this case, what we're showing here are data that is historical, more on the top side, and then more real time on the bottom side here. So we're starting to see the need to merge both historical data and real time data. And some of these technologies here, there's newer versions that are branded, but these were the open source versions of how we model this different type of data. So Kafka for event streams, some of you are using RabbitMQ. For those incremental views, tools like Spark and Storm. And then for all of the data, you would have some MapReduce views. This is where Hadoop came in, but those that in turn feed a warehouse. So the merge view could either be HBase or Cassandra. These are some of the underlying tools that you're seeing today available from either Snowflake or any of us others. But the point here is there's been quite a bit of changes in how we've needed to merge more real-time data in addition to all of our historical data. So on the left side, this requires a lot of architecture, and this is why we talked about in a previous session why you need an engineering team. You're dealing with ingestion and parsing it. And one of the things we like to see is trying to keep that raw data immutable in its original point. And then you'll need to typically go through a cleansing stage. So you might hear the term ETL. There's actually more going on. There's accessing the data, ingesting it, parsing it, preparing it, describing it, profiling the data. You transform it at some point. And then when we say extract, that's typically the extraction and then delivering it to the next system down there. The order may be different, but there's a lot of different steps here. And typically there's a separate set of tools just to manage all of this in your environment. And people that start out down this path start out with their own homegrown tools, but eventually they grow into more advanced tools. So one of the things we like to see is just making sure you separate this. We see a lot of our clients have had many years of historical data or trying to do analytics on the OLTP systems. And they start to see there's performance reasons there because the data is modeled very differently. The transactional systems are typically highly normalized. They're highly normalized in order for rapid write. But for analysis to be able to look at a lot of historical data, you have to do tons of joins, and that really reduces the speed on your systems. So those data models are different. And again, their availability is different. So we like to see people protect the OLTP systems from their analytic systems. And if possible, try to make sure that you get the data out of your transactional systems asynchronously. As we talked about in our sessions in availability, anytime you're pulling data that could impact the querying of your source system, you're reducing the ability for other systems to write to that. So that's why we like to see a clean separation of analytics from your transactional processing systems, although all of our transactional systems start out with some base reporting out of the gate. So step one is just at least making sure you have a separation of your data for analytics. Another thing to keep in mind is if you can, start separating those teams out. They're different skill sets, particularly for the data scientist. As we mentioned previously, data scientists are doing more of the induction. They're trying to find answers to various nebulous questions, and they may be very good at telling the story in both business terms and technical terms. But engineers that have designed the transactional systems typically are very focused on meeting specific needs and requirements. So those teams are different. Also, analysts are typically different. So, and it's always a debate in a company as they're merging, where should these teams sit? Should they sit within product? Should they sit with engineering? Should they sit within the business? You really want to think through as each chain, as each step along the way, where are those teams best fitted? So most teams start out with either the analytics team and engineering team within the engineering group. Sometimes it starts out within a IT group or a finance group because that's the first group trying to do some more aggregate analytics. They may start at reporting to a CFO or a COO or a traditional CIO in that side. And ultimately, as those demands increase, they have to move those teams back into engineering because they lack the overall skill set to manage these complex systems end to end. When I say complex, there's a lot of stuff end to end here. So the best practice we also like to see that we mentioned in a previous one is the hermeneutic circle. And the idea here is moving between induction and deduction. And we'll have a slide later on. But as you recall from the previous session, induction is generally better in the data lake side of your pipeline, and deduction is better performed typically in the warehouse and in the data mart side of your business. So just a quick question for those that have attended. Since the last session, any of you that may have heard the hermeneutic circle term before, have any of you asked your friends, have you heard the hermeneutic circle before? I'm curious if any of you, I think everybody on the call had said they had never heard of that term before. All right.
Yeah, yes,
Go
it has
ahead.
not come up. It has not come up in most of my conversations with my friends.
Yeah, it's rare. I mean, I haven't heard it in 50 years, more than twice. So the only time I heard it was for people that have gotten their PhD. So if any of the new folks have heard that term, definitely you can put it in the chat and let us know if you've heard the term the hermeneutic circle. But the idea is moving between induction and deduction, and there's different parts of the architecture designed for that. All right. As we mentioned, there's typically a need to have an operational data store, which is pretty common, which is an aggregate view that looks more like the transactional systems before moving into the data warehouse view. So that operational data store, again, is multiple online transaction processing systems. It's more normalized, but it's typically a view that's done in order to manage the data movement. In some cases, people keep this permanently. Sometimes they just keep some very recent data versus historical data, but it's also used to facilitate the transition of data from multiple transactional processing systems into the data warehouse, or as a way to do some baseline reporting that takes some load off of your transactional processing systems. So keep those historical models, and you'll also sometimes see some NoSQL solutions in this case because it's very read heavy versus write heavy here. Now, one of the things we like to see also is what we call our independent variable testing. So recall when you want to test some scenarios and do some hypothesis testing, as you related to back into the independent variable is what you're trying to manipulate. The dependent variable is what you're trying to experiment with. So as an example, if you change a feature in your platform and you want to do some blue-green deployments, you may end up doing analysis in a warehouse or a data mart, but the changes are going on the source. Or let's say you have an external system, such as a marketing system or a pricing system where you're making the changes. A later system is probably doing that analysis of what you're trying to determine. So just keep in mind that your independent variable and dependent variable may be being performed in different systems, and why you need multiple systems to do a lot of your hypothesis testing as you're building your features, or actually trying to not just build your features, but change the way people interact with your platforms. So another thing we like to show, we have a ton of cubes for all of you that have seen our cubes. But one of the challenges in this, and when you have all of these different environments, is what data to store, how long to store it, and a way to think about where I need to keep the data, because it gets very expensive to keep all your data forever. So we've come up with another cube, and it's really around knowing where to store your data and thinking strategically about it. So it's really applied to recency, frequency, and monetization, which is determining the value of your data. In the bottom level left is something that is very seldom accessed, and it could be very old, and it really has no value. So that's data that's in the bottom left. Stuff in the top right is it's always needed frequently. So that's typically data that's been written perhaps in the last hour, the last day, the last month, the last year. The frequency is how frequently do you need to get to it, and that's after it's written, how often do you need to read that data? And then lastly, how valuable is it to your company? Where is it providing the most value? So the more you are in that upper right quadrant, that's where you want your most high performance systems, whether you want, your fastest speed disk, your fastest speed processors up in the top right. And again, that's your most expensive compute. So you don't want everything in your most expensive compute. So it's a way to look at classifying your data, and it's a simple framework to know where to put your data and how to spend the money on different aspects of your data. So think of this not just for analytics, but overall through your entire footprint of all the different systems that you have. So let me pause right there. How many of you today are using lower cost storage for less frequently accessed data? Reginald, can you just share a bit? Yeah, share a bit what you're doing today and how you're doing that.
So, what our our smart infrastructure team did was we stored a database that we no longer utilize. And then what we've done is move all those things to stored, I think AWS cloud copies, so that we don't have to pay for them to be always active. And what we do is we kind of scale up in case we need to utilize them in the future. So we just store them right now and go for it with utilizing the current data that's coming in from our current transactional source.
And how do you, if you need to get that data, how do you pull it out of there? How do you
Uh,
restore it?
we we're, we've created S3 buckets and we've used a tool called Retool
Hmm.
to create an API or create a process to connect to the S3 buckets and bring those back through different JSON formats.
Got it. Lincoln, you mentioned S3 lifecycle management. How are you guys using that today? Is it pulling from relational systems and writing to that? Or tell me a little bit more about how you're using lifecycle management.
It's basically policies configured to push data that's less frequently accessed to lower cost storage tiers.
Got it. How is it getting it from a relational system? Or is it not written from a relational system? Is that just written straight to
It, it,
S3?
it's straight to S3.
Got it. Okay. Very good. All right. So it's helpful if you have some lifecycle management tools to have it automatically apply policies that you have to move data to lower cost storage. So in some cases, you might need to pull in others to help you implement retention policies. And it's helpful though, if you as a technology leader can show the value of why you want to do this. But ultimately, if you're missing the retention policies, you might need to bring your legal team in order to help you write some policies and address data that may be historical where you didn't have these policies. Reginald, do you have a question?
Yeah, I did. I was thinking in the market, is there an AI that specifically around like strategically knowing when you can, move data that's no longer as important, especially based off of different agreements. So like, usually you have like a 2 or 3 I apologize. Usually you have a 2 to 3 year kind of agreement to keep
Hmm.
data. And then after that time, it's no longer important. Has anyone heard of an AI tool that does that automatically for you? Because I think that would be valuable.
I'm not aware of that, but I'd be happy to search that and research that for you, or at least do some analysis on that. It makes sense. I think you could definitely experiment to suggest opportunities for items that should be archived, but it would be hard to get it by your legal team to approve that, to say that you probably still want a human in the loop to make sure you're comfortable doing that from a policy perspective, because they're always worried about either getting sued, or the other big challenge they're worried about is somebody's going to ask you for that data and you have an obligation to provide that data in a certain amount of time. And that's really what they're thinking about. It's from a lawsuit and their ability to respond to a lawsuit. So I wouldn't be surprised if there's tools that can help suggest that, but usually you need some policies to help enforce it to suggest that though. So good question though, and a good idea for a product. All right. So one of the challenges that we mentioned earlier that we typically see, and this is usually for software as a service providers, and they're no matter what size they are, is you're providing a software for a company and you have to ultimately have some analytics within the product, but also for your business itself. And these demands may come from different parts of the business and they may land on different teams. So what what I want to walk you through is some of the typical challenges of what to look for and how to potentially solve them. And it's challenging to solve because you have a small team trying to support 2 or 3 different stakeholders. And as we talked about in some of our previous sessions, we like our small, durable, autonomous teams to be no more than 8 people or so due to the cost of coordination. But it's hard for a team of 8 people to support 2 or 3 very different personas or stakeholders and determine how they allocate resources. So I'll walk you through some of the business challenges, what to look for, and then potential ways to restructure your teams when you have to deal with these very diverse audiences. So things to listen for, and it's this really 3 big buckets here. One is the embedded analytics in your product that you have today, whether it's a B2C or a B2B. So you may hear customers want better reporting and analytics. The end product thing that you built today is too slow. We know a lot of folks that have had to buy tools like Tableau or others to access their data. And then you may eventually find, hey, we want to monetize our data and sell our analytics at another price point. And it's sometimes challenging to do that if you don't have that capability today, or you're dealing with an older technology. Then there's the core chunk of just operational needs within your department. So this could be customer support, it could be marketing, it could be sales, it could be the CFO. Each of those has needs just to do analytics to better serve their particular constituents or just to do their job. And then lastly, the metrics and reporting. This is at a more strategic level. These are things the board is asking for, the CISO is asking for, future reports, or just even auditors, an example. And you may hear these challenges like the CEO is saying, we want to become a data-driven company, or we have so many reports. We hear this one the most. We have reports, but they don't tie out. If I go to this system, it doesn't match up. And for some people, they say, we got to create these reports for the board. They're so messy. It takes one person a month just to do every board report. And ultimately, that leads to we don't trust the data. So those are things to listen for, those three different buckets, if you have those in your environment. So let me just pause there. Are any of you, by show of hands, hearing those challenges today? And I won't call you out. Yeah, very common. Yeah, you hear those all the time. All right, very, very common then. All right, so let's go through how we try to solve for these problems. And we're going to go through first the root cause. So challenge number one is what we call fragmented silos. And those are on the drawings, everything on the left. There's a lot of data, but it's fragmented among a lot of different systems. So if you think about your marketing website, that's going to have page views, visitors, click-through rates, conversion rates. That's one particular silo that's often in WordPress as an example. Our site is not in WordPress. Victoria loves our site, our CMS system, which that's a bit of a sarcasm there. You also have your core product or app itself. So how are people using your core product? What's the usage rate? How are people navigating through? What's the conversion of people in there? And are we actually using features that we've built within the platform? So that is just one silo of data also. Then you have your marketing CRM. So there's a lot of different metrics in there you're trying to get, the quality of traffic coming in, you're scoring leads, what stage are they in, what are some attributes about those? As we talked about in the journey mapping, as people get further along in the journey, you can ask for more information, capture more information, and you start to see their behavior. So you're starting to build out certain personas. Then you have your support tickets. So this is typically yet another system. You're looking for open tickets, response times, how many times can we get first-time resolution? And you also may have data about conversations back and forth. This is where the first place people typically put in their AI tools, their chat tools, and you're trying to get sentiment analysis. Those themselves may be in multiple systems, and that's your chat tools that I mentioned here. So chat itself is its own silo in a way, because you're looking for response times because it's a different channel than perhaps your email system or your phone system. And so you have different analytics there. Your outbound campaign systems that we talked about, not just CRM, but just an email system. We use MailChimp as an example. We're looking at impressions, open rates, click-throughs, people that bounce, unsubscribes. And then your sales CRM, which may be different than your marketing one, which is really where salespeople are compensated and measured. And you ultimately determine win rates because that feeds your transactional systems. And lastly, your core financial systems needed to run your business. Okay. That's typically the last in a lot of different processes, but that's where you're counting for whether you made money or not. You're seeing if people did renew or not. You're tracking, did we get paid or not? And so those are all different silos, as you can imagine. Even a company as small as us, we're less than 20 people. We have how many systems, Doug, between you and Victoria, would you say we have, even for a small company? We're over 10, right?
12 to 15.
12 to 15, yeah. So this problem is even for a very, very small company, and it only gets worse as you get bigger, okay? Although the number of systems doesn't increase as much, it's still a problem even for very small companies. The problem too, though, is that the data that you're really looking for is the higher level metrics is an aggregation of data from multiple systems, right? So, and this is how your leaders are thinking, or you as leaders are thinking overall, just your unit economics. So what's my cost to acquire a company, to acquire a customer? Because that is coming from all of my marketing spend, all my sales spend, anybody in product that's on a call. What's my cost to serve? That's all the labor that's coming from your current engineering team or your customer support team. There's all different unit economics. All these I've mentioned here in this, the unit economics bucket comes from multiple systems. Same with your health score. As we talked about with availability, to look at the overall health of your system, you need to look at a lot of different views to know, is it up? Are customers happy with it? What are customers saying? Marketing ROI. This the common thing you hear from every leader of marketing is they say, I'm wasting half of my marketing dollars. I just don't know where I'm wasting it. I don't know which half that is. So that's the challenge in marketing. Your sales pipeline, you're trying to determine a lot of data there. You would think you could get everything out of Salesforce or HubSpot, but there's typically more data that you need out of your sales pipeline tool. And same thing with your app feedback. Just within your core application, you're pulling data from a lot of different systems. You're trying to get it from your customer support system, all those interactions. And then lastly, just DevOps. Your ability to deliver features fast, even that pulls a lot of data from your different systems, whether it's coming from Jira or Azure DevOps or even ticketing systems and maybe even time tracking systems. You're trying to determine how fast can you build something. So that's the time from pulling code, pulling a ticket, all the way to deployment, how fast your teams are moving. If things do break, how fast can you restore something? And then how much labor does it take to push stuff to production? So these are all big metrics that commonly span different systems. So in order to do that, and then there's the third one I mentioned, sorry, which is reports that you've built into your platform. So a lot of times when you start to have a platform, you build some native reporting in the system, and those are typically views. We've seen a lot of our customers actually build distinct tables or views in the database for fixed reports, right? That's a developer team that's done that. And so to change those reports, it's very difficult to modify those. So then you get scope creep, and you're adding the ability for your customers to add columns to different analytics. What they're really looking for, though, is self-service data and analytics. So a tool like a Tableau type experience where they can explore, or they take the data out of your system, pull it into their analytics system, and do that kind of analysis. So those are the three problems we described, that you've got data everywhere in silos. The metrics you're looking for are in different systems. But then the third one, which is very different, is customer facing. This is a product experience. And you need to think of this like it's a part of your product. People just expect a very smooth interface. They don't want to see your transactional flow where it's all nice and smooth with a modern UX. Then you go to your reporting system and it looks very dated or antiquated, unless you just have a small number of customers using that. So those are your three challenges. And as we mentioned before, how does a small team of 1, 2, or 8 support all those different folks? So I'm going to walk you through some examples from some of our clients and two different challenges and how they solve those. So the first one we're going to walk through is an automotive software as a service provider. This particular client of ours, they built software primarily for car dealerships, and they had a 7-person team, and they built a real nice infrastructure using AWS, Snowflake, and Looker. But this was right during COVID, and so that the whole team left because they were skilled up on Snowflake, and they called that the Great Resignation within their company. So they also had a challenge of two different monoliths that were trying to feed that data. So we came in and did a review of the architecture. I'm going to walk you through that architecture just so you can kind of see some common elements of what you would expect. The second case study is for a payment software as a service provider. And this was a company that was trying to build a platform from 7 acquisitions. They did different payment processing for various different vertical markets. And they needed to do an aggregate view so they could start collapsing platforms there. And their challenges were finding out who the data owner is. So let's jump into the first case study here. And going back to our example from last week, we're showing the data, information, knowledge, wisdom chain. So we talked about a high level, change data capture, capturing it from the source, pushing data into a lake, ultimately into a warehouse, then a data mart, and then having some metrics or front-end tools. And ultimately, the goal is better outcomes. You want employees and customers making better decisions based on what they have. So looking at it, and then across all this, you still need your data operations, which is you're moving all this data. You need your dev, test, deploy, your monitoring, your orchestration. So it needs the same kind of engineering that you would have in your core product. So let's take a look at these different buckets here for this small SaaS company. There were a total of about 30 engineers, and they had a separate team of about 7 people that built all this out. So their primary transactional systems were MySQL databases, and they were both big monoliths. I shouldn't say big, but they were pulling some data from the read replicas. Remember, we talked about you want to use a read replica to avoid impacting the write transactions for your core users. So they used something called Data Truck, which was just pulling the deltas from MySQL, and then they put those into AWS using S3 buckets. And so they had these long chunks of how they were pulling that information in. Then they pushed that data into Snowflake. So they actually call that more of a marsh. They had some base tables. It was also an operational data store. And of course, they had error tables to detect if there was some schema drift on the source. They also had their whole marketing technology stack. So they were pulling stuff from Salesforce via APIs. And they actually used 2 tools. One was Workato, which was kind of like a Zapier type tool, which is looking for changes that are occurring. It's kind of a low code solution. And so it was looking for some real time events, but also some hourly events. And they also had, using a separate tool, kind of like Workato called Stitch, where they were pulling some internal transactional things coming in from Braintree. And then they had data, some third party data from Gainsight, and they used a Snowflake connector there. And then the last thing they had was some data that should have been coming from their transactional financial system. They were NetSuite folks, but they weren't able to convince the finance team to pull the data from NetSuite. So they had an MS Access export from NetSuite to do the financial data that they were pulling into Snowflake. So once they got into the base tables, they used DBT to then push into Snowflake. So DBT was doing some of the transformations. So let me pause there. How many of you in the chat are, or in the view, are using Snowflake today or DBT by show of hands? Very good.
Anyone
And
still
then
using Microsoft Access for anything? That's not a tool we hear of very often, thank God.
Do any of you pushing just Excel right into your warehouse, into your reporting tool? Yep, using both. Yep, no Access, the good old days. Yeah. How many of you using DBT or a different tool?
So we're using a different tool.
What are you using?
We're using ThoughtSpot. We're getting off of Snowflake and moving to ThoughtSpot to use. And then using ThoughtSpot, we're going to use Databricks as our engine.
Got it. Very good. All right. So let's keep going into this case study to see how they move the data further to the right. So we talked about Snowflake. That had the fact table and dimension tables. From last week, remember the fact tables are generally they're a smaller subset of views that make it easy to do quick aggregate queries, and the dimensions are ways to slice and dice the data. So the common ones for most folks are an easier way of organizing products is a particular dimension. In some cases, regions is a dimension, or geography. So I go from state to maybe regions, maybe down to zip codes, and you may have different ways of organizing and slicing that data. Time is the most common dimension. So how do I go from how did I do last week, last month, last quarter, last year in different slices? So as you can imagine, if you try to do all those queries across your transactional systems, you have joins of 10 plus tables. So that's why we have the fact and dimension tables. It reduces the queries. So this particular client, they used Looker, and Looker was used by 3 different constituents to access their SaaS system. So one was the dealerships themselves, car dealerships, and then car dealerships are often owned by dealer groups. So in your neighborhood, you may see the same company name own different competing brands. They may own Ford and GM, but in different locations. And a lot of these groups have been bought up by private equity. So there could be dozens, if not hundreds of dealership groups. And so that's a whole different audience trying to look at data across even more particular dealerships. And then lastly, you have the OEMs. These are the Fords, the Audis, the Toyotas, and they're the ones that really drive behaviors of what software the dealerships are buying. So those are much higher level aggregate views of data. So they provided Looker for that particular group. Internally, the team was just starting to implement OKRs. And so they used preset versus Looker, and that was for them to determine how well are they capturing market share, capturing certain segments of the market, and it was all pulling against a preset. And of course, like any company, they had something before, and their previous solution before Snowflake was treasure data, which they had to deprecate. So not only did they have to build out this new infrastructure, they had to wean people off of the old infrastructure. So very common for any company. And this company was only 10 years old, if you can imagine. They had already had a lot of technical debt they needed to get rid of. And to make all this work, they were using a mix of Go and Airflow and Python scripts. They were using Airflow for orchestration. They had some Jupyter notebooks to do some of the transformations, and they had to do some CI/CD there with CircleCI and GitHub to monitor on this. The team was going through an exercise of going from Prometheus and Grafana to Datadog because a new leader came in, and so more and more tools into the stack just to manage how the information flowed, only for analytics. And then the team emerged, found that they wanted more data. So in this case, because they provided software to a car dealership, they actually had devices in the cars to stream data from the cars. And so that's a whole different kind of data with a different profile. So they had to build out a whole different stack in AWS to pull that data coming from the vehicles themselves. They made the mistake of putting that data into Snowflake, right? So as you can imagine, Snowflake's very expensive. It's probably not good for streaming data coming off of IoT devices. So they had to move that away. So, but just to show you the challenges of what they faced and what a 7-person team was able to build within 2 years, then the whole team left and a new team had to come in and replace it though. So let me pause here. How many of you are dealing with real-time data today coming from IoT devices? Are any of you dealing with that today? Yeah, Lincoln, can you share what that data is?
It's not IoT, but
Okay.
it's